Welcome back to the PDDL Back to Basics. Now we'll start stringing many of these elements together. We'll reinforce what we already saw at glimpse about temporal planning. We will use objects, we will use numeric values, and we will do it in an exercise where we'll greet number of colleagues. And for bigger meetings, we will just greet everyone else in the room and not going to shake hands with everyone. This is the structure of a durative action, therefore. Parameter still the same, but duration is a new element. Precondition has been renamed to condition, which could be at start, overall, at end, as well as effects. Could take place at start, at end, or there actually will be some more advanced effects that take place gradually. About that in the following video. Now, on top of that, we will face two challenges. One of them is can the planner actually work with realistic times of how long we speak to whom, and let's see what kind of how does it affect the search behavior and the heuristic guidance, as well as some gotchas if actually our model can work in corner cases where there actually suddenly are too few people in the meeting room and our model was expecting a high number of people. So let's do that. And again, we will start from an embryonic hello world, and I will just run that to see that it does work. It does work, but it produces an empty plan because we have an empty goal. But the begin here version of the exercise files have already the type defined for a colleague. Again, we are walking into a meeting room full of colleagues, so that's the colleagues. And the state vector is going to keep track of whom we've greeted, whether we said hello to everyone else, and also it's keeping track of number of people we've greeted. So as a first step, let's again convert this from an action to a durative action. Duration of, well, it's saying 5 here, so let's make it 5. Precondition needs to be renamed to condition, and condition needs to be classified to at start. And effects. When we said hello to someone, we should really gather the benefit of it at end, as well as increasing the counter. We increase it when we are done greeting that person. Let's just make sure I'm closing all the brackets correctly. And maybe I'm not, or what is it? I'm missing a requirement, durative actions. So now we have a durative action, say hello to colleagues, and let's just test it. Usually it's a good idea to test incrementally that the model works. So set hello to, who's our first colleague, Angela. So let's see. Can we greet Angela? Yes, we've just greeted Angela. Perfect. So our action works. And the model should be such that we greet certain number of people. So let's try that by setting a goal. Test goal that we've said hello to at least 3 people. So presumably there will be Angela, but there will be 2 other colleagues that we greet as well. Let's look at that. And indeed, we greet Angela, Stefan, and Victor, and we speak to them all at the same time, which is not realistic. So let's again check that at the start we are not speaking. a new predicate that we will use for that locking mechanism. At start, the effect will be that we are speaking, and at end, we are again not speaking. Rerun. So there we go. Hello, Angela, Stefan, and Victor, all one after the other. So we can apparently speak to individual people, or we can set a goal to greet a number of people. And now we set, rather than saying how many we have to greet like that, let's let's say if we've greeted enough people, then we want to greet everyone else in the room. So first of all, we should modify this so the magic number isn't really appearing in the goal like that. So let's create a function for it. Number of individual greetings. Let's say we want to greet 3 people. So now the goal could be, let's greet that many people. And that is a function we need to declare here as well. So let's try that. There we go. We are greeting 3 people. Let's get rid of Angela like that. So the planner gets a choice of whom it decides to greet. And then let's greet everyone else. So if we are greeting everyone else, it should be a durative action. Greet everyone else. Another hello everyone else. And say that there's a duration of 1. And it has an at start condition that we are not speaking, and at end condition not speaking, and at start effect speaking. So we just interlocked it the same way as the other action. So we are using the same locking pattern here. And then we can perhaps get rid of these empty ones. And then how do we trigger that how do we make it show up in a plan? Well, that is done by declaring a predicate. And don't we have it? Said hello everyone else. There we go. We had a predicate for that already. There it is. There it is. And we have to add it to the goal. So now we greet that many people and we say hello to everyone else. Will that work? Let's try. No, it is complaining about problem file not correctly closing all brackets. Sorry about that, my mistake. So now we greet 3 people, 3 randomly selected people, and we greet everyone else, but not that way. We have to greet them at the end. So how do we modify that? How do we prevent that action from kicking in that early? Did we tell the planner that it needs to start after we greet everyone else? No. So actually, a simple way of doing that is taking the condition from here and putting it as a precondition right here. So we first greet enough people individually, and then we say hello everyone else. So there is a causal relationship between the individual greetings and the bulk greeting at the end. So it works. And if we want to greet a different number of people, we just increase or decrease this limit and just rerun, and we'll basically be making different selections there. Now, the first challenge was to make this realistic. So different people with differently long names actually take different time to pronounce. So that will be a way of making this model more realistic. So instead of saying I'm here, that greeting everyone takes just 5 units of time. Let's say these are seconds. Let's make it hello duration. And hello duration will be a function. So there it was declared. Time to say hello to someone. I should have actually decorated that with an argument of time type colleague to make it different for every colleague. And now we shall duration 3, 4, 5, 6. Let's put Angela here. Actually, Manuel, Mark, Paolo, and we're gonna leave Victor out of this. And we are going to say, actually, instead of Mr. Victor, let's make some very long name. Victor's very long name. So I will hello. Like that. And now this is length 15. Well, this is 6. This is what, 8 letters. 4. Let's say it takes 1 second to each of them. So will it make any difference? Let's make it start with A, just so that you can't say this is all because of some alphabetic ordering. Now, we've modified the model so that the duration is specific to the object of the action. And we start seeing the effect. Hello, Mark, Paolo, Angela, Stefan. And if you look at this, you notice that the actions here are ordered by the length. And because the planner, how does it actually try to come up with good plans? It is because it has a metric. The metric implicitly, if you don't declare it, is described as total time. So now I've made it explicit what the default anyway is. So adding this doesn't change anything. It is trying to achieve the goal with the least amount of time, with least amount of actions or least amount of time. And that's why we never get to select the person with that very, very long name. And if we say we just want to greet, say, 3 people, there we go. It only greets the 3 with rather short name. It never greets the one with the long name. So that's one challenge. We made it specific in terms of number of people. But what if we have just, say, 2 people showing up, right? What if only 2 join? Let's take out everyone else. And then I have to comment out these because that's irrelevant as well. Can the goal be achieved this way? Well, let's just try. And there is actually no plan for that problem file because that condition here can never be met, right? So if we say we are never going to greet more than 3 people by their name, then and there are only 2 people showing up in the meeting room, then not good, right? So how do we generalize this to behave correctly, even if there are low number of people? Now, obviously, it will be something to do with this condition here, if that's the one that is not general enough. And what should it really be is, well, one way of doing this is to put a logical disjunction here and say that, well, either you greeted all the people that you were supposed to greet by name, or there are, you've greeted everyone that's in the meeting room already. So how do we say that we've greeted everyone? Well, again, we can use the for all condition, perhaps, can we? So for all colleague, all of them said hello to colleague, right? So now we have a disjunction of greeting everyone that, up to the limit, or just greeting everyone that that is there, and that requires a disjunctive precondition requirement. And indeed, because this is a disjunction, right, it basically works as a minimum. Either the hello counter is this, or the hello counter is the number of people. But I don't want to declare another function with the number of people and feed it with the number 2 when there are 2 people here. I can do that using a universal quantifier for all. So let's give that a go. And it does work now. Hello, Angela, or hello, Emmanuel. And then hello, everyone else. So it works. So what we've done was that we've set up a causal link between 2 now durative functions, hello colleague and hello everyone else. We waited for the right trigger, correctly now modeled trigger, to greet everyone else. Once we were done greeting all the, individually named people. And we've generalized the model to also take into account how long does it take to greet the individual people. And we saw the effect of that people with very long names were actually getting demoted in the search process. So with that, I'll stop here, and we have just one more hello world to go, but that one will be the numerically most interesting one. So see you there.